afternoon. I'm Sara McCurry, Professor Sara McCurry, and today we are going to be talking about solutions. I am under the impression that all of you guys in here got your last exam question on solutions, number 3, incorrect. We are just going to fix that today, so let's just jump right into it. So question 3 is about USP ethanol, which is used for medical purposes. It is 95% ethanol by volume. Volume being the key word. At 20 degrees Celsius, pure ethanol has a density of 0.789 grams over milliliter, and USP ethanol has a density of 0.813 grams over milliliter. We want to find the mass percent of ethanol over USP ethanol. So first, before we jump into this problem, we need to understand the formula for mass percentage. Mass percentage, if you remember, is the mass of solute in grams over mass of solution in grams times 100%. However, we are given the percentage of ethanol in volume, which is milliliters in this case. We need to use a conversion factor through dimensional analysis to convert from milliliters to grams, and then we can plug it into the formula for mass percent. The next step in this problem is to use dimensional analysis. We are going to cross-multiply 95 milliliters times our conversion factor, the density of ethanol and USP ethanol, in order to get their volume, convert their volume into grams. Once we have deciphered what the amount of ethanol and USP ethanol is in grams, then we can plug these values into the mass percent. Mass of the solute, which in this case is going to be the ethanol, over the 81.30 grams of USP ethanol times 100%. From this, we're going to get a pretty long number of 92.1955 and so on percent. However, many of you may be tempted to put 3 significant figures because you see that our density is 3 significant figures. However, this is wrong.
How come we only have 2 significant figures?
It's important to note that any quantitative value, whether it's mass, temperature, that all counts for sig figs. So we need to take into account of 20 degrees and round this to 2 significant figures, which will give us an answer of 92%. Alright class, moving on to part B of the question. We are asked to find what is the partial pressure of ethanol above a solution of USP ethanol at 20 degrees Celsius. In the problem, we are given 2 very important pieces of information that is needed to solve this problem. First, we know that the vapor pressure of ethanol is 44.63 torr, and the vapor pressure of water is 17.54 torr. We will use these factors, but not yet. First, we need to find the mole fraction of the solvent. In order to solve this problem, we are going to need to use Raoult's law. We already have enough information based on the problem to find the mole fraction, which is a part of Raoult's law, based on the information given in the problem previously. In addition, the vapor pressure is already given for ethanol and water in the problem, so this becomes a matter of dimensional analysis. Now first, before we can plug in any values into Raoult's law, we need to find the mole fraction of the solvent, and in this case, we are asked to find the partial pressure of ethanol, so we need to find the mole fraction of ethanol first. From part A of the problem, we know that we have 74.955 grams of ethanol. We need to use our periodic table and look up the molar mass and multiply the 74.955 grams of ethanol by its molar mass in order to get the number of moles of ethanol. I have done this on the board for you, but it does not take a doctor to figure out how to do simple dimensional analysis. Once you multiply the grams of the ethanol, it will cancel out with each other, and you are left with 1.6266 and so on moles of ethanol. Now, to find the mole fraction, we also need to find the amount of moles of water in this solution. Now, we are not given how much water is in the solution in the problem specifically. However, this is a trick question. We can find it. So we know that we have 81.3 grams of USP ethanol. We need to subtract this value to minus the amount of grams of ethanol, and this will give us the amount of water in grams. I have done this simple subtraction problem and I got 6.345 grams of water. Similar as to how we found the number of moles, we are going to multiply 6.345 grams of water times the molar mass, which is 18.02 grams, and you're going to get a number like 0.3521 moles of water. Now, we need to find the mole fraction of ethanol, so we simply need to put the number of moles of ethanol over the moles of ethanol plus the moles of water together. And when you do this as a fraction, you are going to get a mole fraction of ethanol of 0.8220537. Alright, coming back to where we left off. Now that we have found the mole fraction for ethanol, this is a simple plugging it into Raoult's law. We know that Raoult's law is equal to the partial pressure of the solvent times the mole fraction of the solvent. So all we need to do is multiply our 0.82205 mole fraction times 44.63 torr, which was given in the problem, and this will give us a number like 36.68825 and so on torr. Furthermore, we need to round this to 37 torr. To go off what we had with before, we are asked to find the vapor pressure of USP ethanol at 20 degrees Celsius. However, we are only given the vapor pressure of pure ethanol and the vapor pressure of water. So we need to use the vapor pressure of water in order to find the vapor pressure of USP ethanol. We have already found the mole fraction of water in the previous section of this problem, so the big work of this problem is already completed, and we simply just need to plug in our known values into Raoult's law.
I get that we have found the vapor pressure of water, but is this related to finding the vapor pressure of USP ethanol?
From this equation, we have determined that the partial pressure of water is 3.12 torr. However, this is not the answer that the question is asking for. It wants to know the vapor pressure of USP ethanol. In order to find that, we need to add the partial pressure of water and the partial pressure of pure ethanol together. And when you do this simple addition, you're going to get 39.8 torr. Now, as I mentioned before, everything in this problem is 2 sig figs, so we are going to have a final answer of 40 torr. Alright class, this is the last section of this question, and it is actually, quite frankly, the easiest if you've done your work correctly. Part 3 of question B asks, what is the mole fraction of water in the vapor above the solution? You have all the information you need to know to solve this problem. It is a matter of plugging it into the correct formula. In the numerator of the fraction, we see the partial pressure of the water, which we found in step 2 of this problem. And in the denominator, we have the pressure of the vapor above the solution, which we also found in part 2. I am using torr. Some of you may be confused. Why am I using units of torr when I am solving for the mole fraction? We are using units of torr because torr will cancel out and leave us with a mole fraction. These are just showing a relationship. Alright class, thank you for listening. I hope you've learned a lot, and I'm looking forward to seeing you guys in our next lecture.